In example 18.6, we are asked to write an equation to represent each curve. The purpose of this example is really to help us see how different exponential growth and exponential decay functions will compare to one another. Everything in part A is an example of exponential growth. Now specifically, we can look at the blue line and we can see that there is a point at 1, 2. The point at 1, 2 would indicate to me that I have to have the equation y equals 2 to the x in order to make that happen. Take a look at the red line. The red line has the point 1, 3. And the only way I can make that happen as an exponential growth function is to make this say y equals 3 raised to the x. And then finally the green line has the point at 1, 4, which is a good way for us to see that the equation needs to be y equals 4 raised to the x. So although these are all examples of exponential growth, they are each their own parent function. So 2 to the x is not the only example we have as a parent function for exponential growth. There are a lot of them. And what I want you to see here is that as the base gets larger, the growth becomes more rapid. So if I'm looking at that x equals 1 line, looking just at everything along x equals 1, the value for y equals 4 to the x is going to be 4. The function value that goes with y equals 3 to the x is going to be 3. And the function value that goes with y equals 2 to the x is 2. And I think we would all agree that 4 is larger than 3, which is larger than 2. So the larger the base, the more rapid the growth. So if you're talking about investing your money into a stock market or into a 401k, some kind of retirement plan, you would want to go with the growth model that has the more rapid growth. Of course, that depends on the risks that are involved, but as a general rule, these are good things to look at when you're comparing different growth models. On part B, we're going to be looking at nothing but decay models. These are all exponential decay. And for exponential decay, we're going to be looking at the x value -1. So with -1, we have a y value of 2 for the blue line. That indicates that our equation is y equals 1/2 raised to the x. For the red line, we have the point at -1, 3. That would indicate the equation is y equals 1/3 raised to the x. And then for the green line, this is going to be y equals 1/4 raised to the x. So you can see here that there is also a trend with the different values of the base. So for this, as the base gets smaller, the decrease becomes more rapid. And this gives us a nice comparison of the exponential decay and the exponential growth functions.